So, well, if it takes charges to create a magnetic field, then how does the Earth's magnetic field? Is there a little mm, electric current running in the Earth that we don't know about? Certainly not been made by man. It's been there for way before we came around. So what's going on there? And so we see that the Earth has a molten iron and nickel core, and as that turns around and sweeps around, it as because the thing is hot, the charges are pretty free to move, and as this thing moves around and the charges are moving around with the core of the Earth's rotation, it creates a magnetic field. And I'm going to talk a little bit more detail about how a magnetic field is created and how can you figure out what direction the field lines are. What's the field look like for a moving charge? The Earth's magnetic field wasn't always the way it is. The North Pole, the magnetic North Pole was once a magnetic South Pole, and so not the Earth itself, but its poles shift every so many 100,000 years. They say generally at intervals, but they average about 300,000 years. And so the last one was a long time ago, so we don't know what to expect when the next one happens. We haven't been around recorded history to kind of see what effects it would happen, but I would imagine the animals, such as birds and some sea mammals that use the Earth's magnetic field to guide themselves, would probably start going the other way. So there'd be some kind of chaos. Um, we would just recalibrate our instruments, I guess. And this magnetic field that the Earth has is a really important thing. If we didn't have this magnetic field, the solar wind, the radiation from the sun, would generally kill off all kinds of life forms on Earth and not really give it a chance to evolve the way it would have or it could, um, if the radiation is always falling on the Earth. So these magnetic field lines actually disperse those radiations. So the radiation coming like this in straight lines from here kind of get whooped around this and get deflected away from the Earth. And some of that radiation actually kind of travels in little belts around the Earth, and they can be seen on certain days. So here's the solar wind being deflected around by the Earth's magnetic field. And we're really lucky that the Earth does have a magnetic field and it's strong enough to keep the solar wind at bay. And so when these things do pass close to the surface of the Earth, they are streaming past and they give off these cool lights known as the aurora australis in Australia or the aurora borealis in the northern hemisphere. So let's come back to what causes a magnetic field. And what I said was that you needed a moving charge to create a magnetic field. And a tiny atom has electrons orbiting around it. Yes, orbiting, which means it's moving. So we have moving charges. So you'd say, hey, wait a minute, that means everything is magnetic because everything has moving charges. Yes, it is. And all these little tiny magnets are all pointing in different directions because things are randomly aligned. And so generally they just cancel each other out. And we have no net magnetism from most places, uh, with the exception of when there is a certain extra amount of spin in one direction versus the other, and that might cause some residual magnetism, and that's what our general magnets are. The ones that you see, like the ones that you stick on your refrigerator and stuff like that. So some objects are magnetic and some objects are not because of this the kind of electrons, and not the kind of electrons, but where the electrons are placed on their outer shells. We'll look at this in some